السلام عليكم ورحمة الله وبركاته. طلاب المرحلة الأولى level 1. first level 1. محاضرتنا لهذا اليوم linear، موضوع linear الجبرة، lecture 6 محاضرة السادسة، linear independence and linear dependence. linear independence and linear dependence. In Arabic this مستقلة خطيا and this معتمدة خطيا. Definition. Let V1 V2 until Vk belongs to V, a vector space, the set of vectors V1 V2 until Vk is called linearly independent if and only if C1 V1 plus C2 V2 plus until Ck Vk equal to 0. This implies C1 equal C2 equal so on to Ck, all of them equal to 0. We say that the set V1, if this vectors in vector space V, we say that these vectors, this set V1 V2 until Vk is called linearly independent. We call it linearly independent if and only if C1 V1 plus C2 V2 until Ck Vk equal to 0 implies C1 equal C2 and so on to Ck, all of them equal to 0. Then we say that this set is linearly independent. Now what about linear dependence? If the set V1 V2 until Vk is not linearly independent, then we say that the set V1 V2 until Vk is linearly dependent. So if one of C1, C2, Ck until Ck not zero, non-zero, if we have linear combination of C1, V1, V2, Vk, this equality with zero, and sum of C's not zero, then we say that these vectors V1, V2, Vk until Vk is linearly dependent. If all of them of all C is zero, then we say that this set V1, V2 until Vk is this set is linearly independent. So now we have to take examples to show this. This is page number 1. First, we take this example. Example 1. Example 1, let V1 equal to 1, 2, 3. V2 is equal to 2, 0, 1. V3 is equal to 0, 1 minus 1. This belongs to R3, 1. 3 times 1. 3 times 1. R V1, V2 and V3 linearly independent or linearly dependent. Show that. Now solution for this example, we take 3 vectors V1, V2, V3 in R31, 1, 2, 3, 2, 0, 1, 0, 1 minus 1, and now we can take linear combination of these vectors and see what about real numbers if someone not zero, so we call it this is linearly dependent. If not, we call these vectors are linearly independent. Solution. Take linear combination with these vectors C1 V1 plus C2 V2 plus C3 V3 and make it equal to 0. This 0 will belongs to R31 because these vectors in R31. So C1 times 1, 2, 3. This is V1 and plus C2 with V2. V2 equal to 0, 2, 0, 1 and plus C3 with V3 0, 1 minus 1. This is equal to 0, 0, 0 because this is in R3, 1. So now we can move these real numbers inside the vector and sum of them and try to compute values of C1, C2, C3. Now you can move it here. This is C1, this is 2C1, this is 3C1 plus 2C2 plus 0 plus C2, and this is 0 C3 minus C3. This is equal to 0, 0, 0. And now sum these vectors. sum these vectors c1 plus 2c2, and this is equal now this is will be look like this, 2c1 plus c3 here, sum this, and this is 3c1 plus c2 minus c3. This is will be equal to 0 0 0, and now we can move it to equation. This equation will be c1 to c2 equal to 0, and 2c1 plus c3 equal to 0, and 3c1 plus c2 minus c3 equal to 0. And this we can move it to matrix. This matrix will be here 1 2 0, and here this is equality, this is 0, and here 2, and this is 0, and this is 1, and this is what, 0, and here 3 1 minus 1, here 0. And try to solve this system by Gauss-Jordan method. And this is page number 2. Try to solve this system by Gauss-Jordan method. So now we take, this is here, this is matrix here, 1 2 0, and here 0, and this is 2 0 1 0, and this is 3 minus 1 minus 1 0, and try to solve the system to find, if we solve this system, that means we find c1 c2 c3, and we want to find values of them. So now we can do it by Gauss-Jordan method. 2r1 minus r2, write in r2, this is implies the same, r1 1 2 0, and this is 0, and r2 will be 2 minus 2 will be 0, and here 4 minus 0 4, and here minus 1, and here will be 0. And also the third row, 3r1 minus r3, write in r3, and here 3 minus 3 will be 0, and here 6 minus 1 will be 5, here 0 minus 1 will be 1, this is 0. Sorry, here 3 minus 3 will be 0, here 3 minus 3 will be 0, and here 6 minus 1 will be 5, and here 0 minus 5 will be plus 5, and here 0 minus 0 will be 0. This is what we get. Now we try to make this is 1 over 4 r2 in r2, write in r2, this implies this is the same, 1 2 0, and here 0, and here 0 1 minus 1 4 0, 0 5 1, and here 0. Now we try to make this is also 0. We try to make this is 0, 5 r2 minus r3, write in r3. We get what we get, right, just in r3 here. So this is 1 2 0, and here 0, and here 0 1 minus 1 4 0, Here will be 0 minus 0 0, and 5 minus 5 will be 0, and here minus 5 over 4 minus 1 will be minus 1 4. Okay, because this is minus 5 over 4, that means move 1 will be minus 1 over 4. This is will be 1 over 4. And now we try to make this 1, and we can do it by this is minus 4 R3 right in R3. This is will be the same 1 2 0, and here 0, and here 0 1, and here minus 1 over 4. Okay, you can sum this with this, and here will be 0 before this. Yes, we can do it look like this. This is not, we not it now. R2 minus R3 right in R2. R2 minus R3. So 0 minus 0 will be 0, and 1 minus 0 will be 1, and 1 over 4 minus plus 1 over 4 will be minus 1 over 4 plus 1 over 4 will be, this is will be 0, and this is will be also 0, 0 minus 0, and at the same time minus 4 r minus 4 r3 right in R3 will be 0 0 1 0, because this is minus 4, and this is move will stay just 1. The result is 1. Now also we can make this 0 2 r minus 2 r2 plus r1 right in r1. This implies 0 plus 1 will be 1, minus 2 plus 2 will be 0, and here 0 plus 0 will be 0, and here 0, and here will be the same 0 1 0 0, and here 0 0 1 0. So now this is Gauss-Jordan method. We get this is identity. So we have C1 equal C2 equal C3, all of them is equal to 0. Hence V1, V2, V3 are linearly independent. Because by definition, if we get all of C's 0, this is definition, we take linear combination of C1 V1, C2 V2, C3 V3. Look like this example, and make equality with 0, and make this is equal to 0. Look like definition, and after that we get C1 equals C2 equals CK. This is C1 equals C2 equals CK, all of them equal to 0. Here K is 3, here K is 3, and now we get this is vectors are linearly independent. Okay, we take another example, example 2. We take example 2. This is example will be look, this is example. Let V1 is equal to to 1 0, and V2 is equal to -1 3 1. V3 is equal to 1 0 1. This is belongs to R 3 times 1. R V1, V2 and V3 linearly independent or linearly dependent. Show that. This is page number 3. And now try to solve this example by the same way. You can first solution. We can take first linear combination of these vectors, equality with 0, C1 V1 plus C2 V2 plus C3 V3 is equal to 0, and this is 0 belongs to R3 1, because these vectors V1 V2 V3 in R3 1. So now we substitute C1 V1 2 1 0 plus C2 and V2 minus 1 3 1 plus C3 and V3 equal 1 0 1. This is will be equal 0 0 0. This is example. Try to show that this is linear independent or linear dependent. So move C's here, and this is will be 2 C1 here 0 plus minus C2 3 C2 C2 plus C3 0 C3, and this is equal to 0 0 0. Now also the same, we sum these vectors will be 2c1 minus c2 plus c3, and here c1 plus 3c2 is 0, and here c2 plus c3, this is will be equal to 0 0 0. And now we move it to equation. This equation will be okay, just light better. Now this equation will be 2c1 minus c2 plus c3 is equal to 0, and c1 plus 3c2 equal to 0, and c2 plus c3 is equal to 0. Now we move it to equation, and this equation will be matrix. This matrix will be, this is linear system. Try to do it by Gauss-Jordan method. This will be 2 here minus 1 here 1, and here will be 0, and here 1, and here 3, and here 0, and here 0, here 1, and here 1, here 0, also here 0. This is system. Try to do it by Gauss-Jordan method. Now divide this by half, multiply by half, 1 over 2 R1, write in R1, and this is, we get 1 minus 1/2, and this is will be 0, this is half, and here 1 3 0 0, and here 0 1 1, also here 0. Now try to do this 0, just R1 minus R2, here make this 0, R1 minus R2, right in R2, implies this is the same, half minus half, here 0, and here 1 minus 1 0, minus half, minus 3 minus half, minus 7 by 2, 7 by 2, because this is 3 minus 3.5, and here the same, 1/2, this is also 0, and here 0 1 1 0. And now try to make this 1, so we multiply minus 2 by 7, R2, right in R2, this is will be here 1 1/2, here half, 1/2, this is minus half, this is half, this is 0, and here 0, and here will be 1, and here will be minus 1 over 7, and here will be 0, because this is move with this, so minus 1, and here 0 1 1 0. Now try, this is page number 3, 1 2 3, and this is 4. Now make this 0, just R2 minus R3 right in R3. This is the same. 1 minus 1 half minus 1 minus half 1 half. This is 0, and here the same 0 1 minus 1 over 7, here 0, and here 0 minus 0 0 1 minus 1 0 also, and here minus 1 over 7 plus 1. This is will be minus 8 over 7. It's because this is 1 7 7 by 7, and this is minus 8 over 7, and this is 0 plus 0 will be 0. Now make this is 1. Look like this, minus 7 over 8 R3 right in R3, and we get 1 minus half, here 0, and here 0 1 minus 1 7 over 7, here 0, and here 0 0 1 0. And now try to make this is 0, multiply this is 1 by 7 and sum. Or multiply this, this is, yes, R2, R 1 over 7, 1 over 7 R3 plus R2 right in R2. This will be implies. This will be implies. Also, also we can move the same time. No. Just no. Other step better. Now we get this is the same 1 minus 1 half 1 half. This is 0, and here will be 0 plus 0 will be 0 0, because this is 1 by 7 0 0 plus 1 will be 1, and 1 over 7 times 1 will be 1 over 7 minus 1 over 7 will be 0, and this is 0 plus 0 will be minus plus 0 will be 0, and this is the same 0 0 1 0. And now try to make this one 0 by use this row. So 1 half R2 plus R1 right in R1 will be get. Here 0 plus 1 will be 1, and here half minus half will be 0, and here 0 plus half will be half, and this is 1, and here the same 0 1 0 0, and here the same also. Now make this 0 by use this row. So R3 minus 1 half minus 1 half R3 plus R1 right in R1 here. This is minus 1 over 3 over 2, sorry, minus 1 over 2. We get this is 0 plus 0 plus 1 0 plus 0 0 minus half plus half will be 0, and this is 0, and this is the same 0 1 0 0 0 0 1 0. So we get now the identity this is identity, so we get values of C1 equal C2 equal C3. This is equal to 0. All of them will be 0, and therefore hence V1, V2 and V3 are linearly independent by definition. We take another example, example 3. Example 3, let V1 is equal to 1, 2, 0. V2 is equal to 2. Okay, make this one better. Make this one 2, 4, 2. Are V1 and V2 linearly independent or linearly dependent? Our question, show that. This is page number 5. This is page number 5. Now we try to do it also the same by use Gauss-Jordan elimination. This is V1, V2 and solution. C1, V1 plus C2, V2, because it's just two vectors, V1, V2, so we need just C1, C2. And this is equal to 0. This is linear combination. This is belongs to R3 times 1, also the same. Now this C1, V1 equal 1, 2, 1 plus C2, V2 equal 2, 4, 2. This is equal to 0, 0, 0. Now try to do it and see the values of C1, C2. Move C1, this is C1, this is 2C2, this is C1 here, 2C1, here C1 plus 2C2, 4C2, 2C2. This is equal to 0, 0, 0. And sum these vectors. This will get C1 plus 2C2, 2C1 plus 4C2, C1 plus 2C2 is equal to 0, 0, 0. This move it to equation. C1 plus 2C2 equal to 0. 2C1 plus 4C2 equal to 0. And here C1 plus 2C2 equal to 0. Move it to matrix. Will be, this is matrix here, 1, there is no C3, just C1, C2, so this is 1, 2, and here 0, and here 2, 4, 0, and here also 1, 2, 0. Now try to solve this system. 2r1 minus r2 right in r2. This implies 2 minus 2 will be 0, and here 4 minus 4, sorry, not here, not right here, right in r2. So this is the same, 2 1 2 0, and here 2 minus 2 will be 0, 4 minus 4 will be 0, 0 minus 0 will be 0. And here also we can make this 0, r1 minus r3 right in r3. 1 minus 1 will be 0, 2 minus 2 will be 0, 0 minus 0 will be 0. So this is 0, 0, 0. And now we have just this equation. C1 minus 2C2 equal to 0. That means this implies C1 is equal to C2. That means there are many values of this C1, C2. Now make this true table. This is C1, this is C2. If C2 0, so C1 0. And if C2 1, this is will be what? 2. If this is minus 1, this is will be minus 2. If this 2, this will be 4. This minus 2, this will be minus 4, and so on. So that means C and C2 not just 0 0, not just 0 0, to say that this is V1 V2 linearly independent, but C1 C2 will be maybe 1 2, maybe minus 1 minus 2, maybe 2 4, maybe minus 2 minus 4, and so on. So V1 and V2 are linearly dependent because this system have infinitely many solutions, not just one solution. In other examples, in example 2 and example 3, in example 1, there is unique solution. There is unique solution, just one solution is 0. And so we say that this is V1, V2, V3, these vectors are linearly independent. Also in example 2, we get unique solution, this unique solution, all of them 0, so because we get identity. But in example 3, this is example 3, but in example 3, we have infinitely many solutions, not just one solution. So we say these vectors are linearly independent. I think this is clear, because this is, so V1 V2 are linear independent because we have not just 0 0, just one solution, but we have infinitely many solutions, 1 2, minus 1 minus 2, and so on. So we say V1 V2 are linearly dependent. I think this is clear and enough for today. Thank you very much.